Okay, so what we're going to look at now is the graphs of first order recurrence relationships. So we've talked about the common difference type, which is what we see here. And we've also talked about the one where it's got a common ratio type we've got there. Okay, so the ones where it's a common difference is what we call arithmetic patterns. I'm sure somebody's going to laugh at that because I can't say it properly. But what we find is that they're a straight line or constant straight line or constant increase or decrease. Okay, and as you can see, increasing positive or decreasing negative in that way. Okay, and as you can see here, a straight line or linear pattern is given by the first order recurrence relations of this form. If I've got them in that form, I get a nice straight line. I'm going to come back and make a comparison between a couple of things in a moment. When we've got the common ratio one, as you can see, it's no longer linear. Okay, so you're either going to get a curve line, which is these ones, or you're going to get a saw form. You're probably thinking, that's these ones here. Where did the saw form ones come up from? If we go back to this for a moment, this is where you'll get a saw form. So it's alternating positive and negative values. Okay, so let's just stick to the top ones for the moment. We'll come back to the saw ones in a moment. So that was just the definition there. Increasing pattern or a positive common ratio greater than 1. R is greater than 1. Between 0 and 1, I get a negative value there. And if it's a decreasing pattern. And as you can see with these ones, if it's less than -1, I get that particular saw pattern. I get the sort of the flip if it's between 0 and -1. Okay, but let's focus on these two for the moment. Okay, because the reason I want to focus on those two for the moment is that we get a nonlinear pattern is generated by first order recurrence relations in this form, where R is essentially greater than 1 or between 0 and 1, depending which one we get that curved line. But what I want to make, as an example, and this is just an example because there's other ones as well, like depreciation and stuff, but you can think of this as simple interest. Okay. And you can think, just as an immediate thing, this one as compound interest. If you start thinking of it like that, what you can start to find is that this is how it links into the financial maths. So when we do financial, you've already seen this, you already be comfortable doing this. So when it asks you to generate a recurrence relationship, you can do it. You know what this form means. You know what this form means here. And it's important that you make that link because that's part of what we have to do. This is just a reminder about the importance of stating starting term. Makes a big difference. And here's just a little bit of a breakdown of the types of sequences. So this one, this is where you're getting a linear increase or decrease. This one here, I'm either getting, depending on what the R value is, or curve line that way. And sometimes you can get this arithmetico-geometric, but I won't go into that at the moment. Okay, so let's go through some quick work examples. On a graph, show the first 5 terms of this sequence here. Okay, so let's have a look. So I've got my UN plus 1, so I'm just going to write in for U1, we know U1 is equal to -5. Okay. let's go U2. U2, it's going to be -5. Sorry, I should write this as, I'll write for this one, but I might not write for U1 -3. So -5 -3 equals -8. U3 equals U2. Well, I lied to myself because I'm writing it anyway. That becomes -8 -3, so it becomes -11. And if you did U4, that's going to be -11 -3, so it becomes -14. Okay. First 5 terms I got 1, 2, 3, 4. So U5 is going to be -14 -3 equals -17. And you plot these terms on a graph. It's going to be very bad drawing. So I'm going to go 5, say roughly 10, 15, and we'll go 1, 2, 3, 4. Okay, so our first one's going to be 5. It's going to be 5 and 1, so I'd put a point there. My next one's going to be 8, so just about roughly there. Third one's going to be 11, so just about there. Forgive my, not going to be very straight. Next one's going to be 14, 4. Surprisingly straight. Okay, and I'm just going to skip the fifth one for now, but you'll get a straight line. Okay. So so to go for, and this is an example where we're looking at where we've got in terms of UN plus 1 equals R UN. It's in that form, so it's in the common ratio one. A better common ratio. It's this one here. It's this style here. Oops, not that one. So what I do for that is I calculate them out again. So I go UN plus 1 equals 4 UN. So when I say U2 equals 4 times U1, my U1 was -0.5. So 4 times 0.5 is 2. So 4 times 0.5 equals 2. U3 equals 2 times, oops. How do I write that? Better way of writing it, it's 4 times 2 equals 8. So I want to highlight it. So that's that and that. They're the same. So when I do the next bit, I go U4 equals U3 times, I keep writing like that. That's why I keep confusing myself. What I mean to write is 4 U3. So it becomes 4 times, what was U3? U3 was 8. So let's highlight. Okay. 4 times 8 is 32. Okay, U5 is going to be 4 times U4. 4 times 32 equals 128. Let's highlight that again. So 32, they're the same. You see the first 6 terms, I'm just going to stop at 5. And if I'm going to graph that, it's going to be very, very bad drawing. You're actually going to have 1, 2, 3, 4. Okay, you might have 40, 80, 120. I'm going to stop at 128, so that's good enough. 4, so I go 5. So it's going to start off really light small, so close enough to 0 there. Then 2 is going to go to, U2 is going to go up to 2, so it's barely sort of there. It's probably even too high because my line's not straight. 3 is going to go up to 8, so it's not even, yeah, it doesn't help if you haven't drawn very well. Oh, this is annoying me. There, 4 becomes 32, so it's sort of, yeah, this is really bad drawing. 5 sort of shot up a bit. You can see the curve, okay? So, sorry about the really bad drawing there. But yeah, that you get the point, I think. You can see there's a curve in the data, okay? Now, the first 5 terms of sequence are plotted on the graph. Write the first order recurrence relationship that defines this sequence, okay? So, what's our first term? Our first term is 18, okay? So our U1 is equal to 18. Got that straight up, okay? But what do I do next? So let's actually go here. All right. My sequence is 18, 15, 12, 9, and 6, okay? Remember, to get a common difference, you need to do, so a common difference is like saying, how do I want to write it? So that's 1, 2, 3, 4, 5. So if I go common difference, so my D is going to be U2 minus U1. So my U2 is 13, 15 minus 18. So I'm going to get minus 3. Let's pick 5 and 4. So if my difference was U5 minus U4, my 5 is going to be 6 minus my U4, which is going to be 9. And guess what? It's going to be equal to minus 3. Okay? So what I get here then is a UN plus 1, because remember, that is my new term, is equal to U, well, actually, if we do it the other way, sorry, I'm just trying to find it. And we go UN minus UN equals D. We've shown that that is UN plus 1 minus UN equals minus 3. That means I can write this as UN plus 1 equals UN minus 3. And where U1 equals 18, because that's my starting value. All right. Now, we can see by the curve on this that this is going to be a common ratio one. So you could think this would be something like flat rate depreciation. This might be compound interest type question, just to sort of get it ready. So you can see in this one here, we know what this one here, that's going to be my U1 is equal to 2, straight up, okay? Then I'm going 2 to 4, so I'm going 2, 4, 8, 16, okay? And so what we can see there, this one's sort of a reasonably easy one to do. You know it's UN plus 1 equals R times UN. We've worked at that common ratio is 2, because I'm going 2 times 2 to 4, 4 times 2 is 8. So that becomes 2 times UN, or we write it as 2 UN, where U1 is equal to 2. Okay. So the first 5 terms of a sequence are plotted on a graph shown. Which of the following first order recurrence relationships describe the sequence? Okay, I think we can remove one straight up. Okay, because we can get rid of C straight away because we can see it's a common difference one. This would be a common ratio one. All right, where we're starting at term number 1, so U1 is 1, so that rules out these two. And what we're left is with now is what is my difference? So I'm going from 1 to 3, from 3 to 5, so I'm adding 2. Okay, so this is the recursion stuff as just pure recursion. As I've indicated a couple of times here, these questions, this ability to do recursion gets repeated in financial, and so you'll need to sort of see where the links are. But if you're comfortable, you become comfortable doing this, it will make your life easier when it comes to the recursion stuff in financial, and we'll be using some calculator tricks there as well. Okay, thank you.